All right, let's try to understand some compound inequalities here, and I'm going to take a very sort of intuitive approach, in my opinion, to this as opposed to a technical approach. Okay, so keep that in mind. Let's first understand what a compound inequality is. A compound inequality actually consists of two inequalities, and I guess you could probably even expand that to three or four or more, but we're only going to look at two inequalities, and so I'm going to call it a system, just as a loose term to use there. It's actually a system of two inequalities separated by and or. And we're going to take, when we try to solve these, we're going to take the literal meaning of the words and or, okay, just to make it very simple. All right, so let's take a look at an example of a compound inequality and its meaning. So here's an example of a compound inequality. You can see it consists of two separate inequalities separated by the word and now let's talk about what it means to solve this inequality. Clearly we've got one variable x, so we're going to figure out values of x that make something true. So to solve this compound inequality actually means to find all x values that makes this inequality true and also make this inequality true. So we're looking for values of x that are less than 5 and also bigger than or equal to 2. So if you were to look at this on a number line, let's mark 2 and 5 since those are our two numbers of interest. 2 is here, 5 is here, let's say. Numbers less than 5 are numbers to the left of 5, right? Numbers bigger than or equal to 2 are the numbers here, basically, and including the 2, and let's say excluding the 5. So I want to know all x values that make both of these true. Well, the numbers that make both of these true are the numbers in the region where they overlap here in this picture. Or you could perfectly easily reason out the numbers bigger than or equal to 2 and less than 5 are the numbers between 2 and 5, including the 2, but not equal to 5. So in either way you look at it, the solution is all the numbers between 2 and 5, including the 2, not including the 5. Okay? So and means you have to make both statements true. So you're looking for all the numbers that make both and make both statements true. Now let's come back and simply change this and to an or and see how that affects what's happening. First thing I want to do is look at the meaning of this statement, of what it means to solve this compound inequality. So now I want to find all x values that make x is less than 5 true or x is greater than or equal to 2 true. So in other words, here I just have to make one of them true for the number to be a solution. For example, 0. If x is 0, would that make this compound inequality true? Well, 0 is less than 5, right? So that would make this statement true. 0 is not greater than or equal to 2, so that would not make this statement true. But 0 does make this or this true, right? It makes one of them true, so 0 will be shaded in our final answer. Now let's see if we can generalize this a little bit to find all of the x values that make it true. Sorry, that should be a straight line. So all the numbers less than 5, right, they're all going to be shaded. We know that. All the numbers bigger than or equal to 2 are also going to be shaded. So every number here makes one of these two true, right? In other words, this is the solution. Every number is a solution to this compound inequality because it makes one of these two true. It makes the first one true or the second one true. Okay? We haven't by any means exhausted all the possible examples here. I just wanted to introduce you to the meaning of compound inequalities and using your intuition, hopefully, to solve them. You can do these with intersections and unions, as was presented in many textbooks. I encourage you to look at that if this method is not working for you.